Welcome, and thank you so much for being here. Um, I want to thank the people who have put on this presentation. I want to thank Agilero, and I want to thank our translators and our staff. Thank you so much for having me here. I want to talk about 5 technical practices that I feel are essential for doing software development with Scrum. Our industry has a lot of challenges, actually. Excuse me. Only 1 in 3 projects will be successful. This is even with Agile. And over $60 billion is lost every year in the United States due to poor development processes. 80% of developers' efforts are spent undoing the decisions they made in the first 20% of their effort. And nearly half of all features, 43% of all features, are never ever used. These are statistics that are well established and described in my book. I feel like our industry can do much, much better. And I think one of the reasons that our industry is not thriving as much as it could is because we don't pay enough attention to the technical practices. Developing software in Agile with Scrum is very different than developing software in Waterfall and requires different skills. And unfortunately, the rest of the industry, the schools and other resources have not caught up. And so in the United States and in the West, what I see being taught in colleges now is information that was relevant 30 years ago, but not so relevant today. And so developers today don't really have a lot of skills in being able to write iterative software that we build in sprints. And when we build software in sprints, we don't get the big picture. We build a little piece at a time. And because of that, the design that we come up with is almost guaranteed to be wrong because we don't have the whole set of requirements. We're only given a little piece of requirements. So one of the important skills that we need to have as software developers is to be able to go from one design to another design, change the design. We call that refactoring in software development. And it's a fundamental critical skill. And yet I find that most developers are not familiar with the discipline of refactoring, that there's actually techniques around doing it. And I was thinking about this last night, and it is as if mathematicians didn't just figure out how to factor the equations. And in mathematics, you can simplify an equation through factoring. Imagine what it would be like if mathematicians didn't have the technique of factoring. E equals mc squared, Einstein's famous formula, would actually be 100 pages long. It would still work, but no one would use it because it would take so long to process it. And this is where we are at with software. The legacy code that runs every industry, everywhere, works, but it's very, very hard to repurpose. And this is what we need to address in our industry, because this is the thing that's costing not just our industry in software, but every other industry, because every other industry depends on us. So I don't want you to make the same mistakes that we have made in the West. In the West, Scrum is very popular, but the technical practices that support Scrum software development are not as popular. Only 1 in 10 teams in the West are doing the technical practices of extreme programming. And about 1 in 10 of those teams are doing those practices correctly. Now, those 1% that are doing the practices correctly are benefiting tremendously. These are some of the top software development organizations in the world, the Microsofts and Amazons. And I get to work with them and I get to learn from them. but they build software very differently than the rest of the world. So developers really need to understand a different set of technical practices in order to build software in sprints so that they're doing it efficiently and effectively. I think software development really drives every other industry and is in very many ways the secret sauce of a lot of companies. When I ask developers what the #1 challenge that they face is, they often say to me, it's legacy code. And virtually every company has legacy code. Code that developers don't want to touch because we have the experience that when we touch legacy code, many things break. And so we're scared to touch it. And that's a very bad place to be in our industry where we're scared to touch our code. Now, it turns out that working with legacy code is actually very straightforward, and you can do it safely if you know the techniques of doing it. But I don't see many people talking about that. I never saw a course in college on that, and I only know of 3 books that really talk about it. But it's a critical skill, and because we have to deal with legacy code quite a bit. I think software development is maybe one of the most complex activities that humans can engage in. And like any other activity, it's really about building models. This is what we do as human beings. We build models. When we write literature, it's a model. When we make a sculpture, it's a model. Or paint a painting, it's a model. And the models that we build with software don't model necessarily physical things, but processes. And the language of software gives us the ability to articulate models at a much higher fidelity than we ever could before. And so we want to take advantage of that. This deepens our understanding of what we're building. I think that the job of a software developer, #1, is to understand what it is that we're working with, to understand the process so that we can embody that in code. And embodying it in code is important because we want to automate it, but it's not the critical skill. The critical skill is actually understanding and being able to create resilient models. And again, I don't see a lot of people talking about this. I see people talking about frameworks and programming languages, but I don't see people talking about problem solving or abstract thinking. But I think you would agree that those are the critical skills of a great software developer. True masters in software development, they have the ability to abstract and understand and represent what it is that they're building in a way that other people can understand as well. And that's very important. We need to communicate through code. So code is not just about making the computer do something. It's also about communicating with other developers, because the code that we write has to be able to be changed in the future. The only software that does not need to change is software that no one uses. But if your company is successful, I can guarantee that you have legacy code. It's the price of success. And the challenge is, how do we deal with it and still remain successful? Yeah. So there are technical practices that support us in doing this. And when I work with the top 1% of software developers, I see that they build software differently than the rest of us. They build code that's far more maintainable. They're faster and cleaner because they have the right habits. With the right habits, anyone can become a master. But we have to know those habits and then make it our own. Experts draw on principles and practices. They have their own terminology. They maybe have their own way of doing things, but all of these things are learnable skills. So if we think the way they think, if we do the things that experts do, we can get the same results. And I've seen this time and time again over my 30 years as a professional software developer. I've had the good fortune of training over 10,000 professional software developers in my career. I think that's probably a record, a world record. And we're a very smart group of people, but sometimes we make things a little harder on ourselves than it needs to be. And so I really stress understanding the technical practices to the point of where it boils down to common sense, because every technical practice really comes down to common sense. In Agile, we build things incrementally because we want to get feedback. And we draw on all these different skills to help us build better, more resilient software. People recognize that writing software requires logic and discipline. But there's also another set of skills that I think people don't really recognize. They're very creative skills. They're skills related to thinking abstractly and being able to solve a range of different kinds of problems. These are the skills that I find that master software developers have. And these are the skills that I want to share with you, because this is how we are able to really build good enterprise software. So a lot of software that we build doesn't require this. If you're just building a little website, or if the code that you're building is just 10,000 lines long, you don't really need a methodology. You don't really need to have good practices in place. But when we're building enterprise software, that's millions of lines of code. When we're interfacing and interacting with different people, we need to have that common ground so that we can connect, so that our code works together well. So this is, on the slide, a picture that I use in all of my courses, because it shows 18 things that I really find are valuable for software developers to understand. Some of them are principles, like OCP stands for the open closed principle. Some of them are practices, like hide by policy or programming by intention. Others are disciplines, a collection of practices that work together, like refactoring or writing the test first. And they're surrounded by 6 key code qualities. Things like cohesion, non-redundancy, encapsulation, etc. These 18 things, along with about a dozen design patterns, are, I think, fundamental. Because when developers understand these 30 things, they're able to do great things with their software. They're able to solve problems that they couldn't. They're able to make code more understandable when they couldn't before. And so that's why I like to stress these 30 different things. Okay. So, it's very interesting because in the West, people are very good at the analytical side of programming. But I find that sometimes in the United States and sometimes in Western Europe, people have a harder time with the abstract side. I don't see that in the East. In Eastern Europe and in Japan and in other places in the East, I find that people understand the abstract side very well. They're actually really, really good at it. And so that's very exciting because I want to share these advanced practices, but I realize that not everyone is ready for it. These ideas belong to humanity. They belong to all people. But unfortunately, some of the people in the West are not quite ready for it. I think Japan is ready for these ideas, and so I'm excited to share them with you. So let's dive in. This is me. Like I say, I've been a software developer for over 30 years. That's kind of scary to say. And I've trained over 10,000 professional software developers at the top companies in the world. And I've learned a lot from the people I've worked with. If you want to get in touch with me, you can go to my website, tobeagile.com. I wrote a book called Beyond Legacy Code in English, and it was, I'm so glad, translated into Japanese as well, so you can read it in Japanese. This is my book, Beyond Legacy Code, 9 Practices to Extend the Life and Value of Your Software. This book really talks about the technical practices in a way that anyone can understand. Because what I found is that there's a gap between the technical and the non-technical people on our team. And very often, the non-technical people don't understand the reasoning behind the things that we do in software development. And so I wanted to stress the importance of these technical practices, why we do them, not just what they are, but why they're valuable. And so there's a million how-to books on the market on how to do any kind of a programming language or framework or anything. But this is the only why-to book that I know. Why are we doing these practices? What's the benefit? What's the value to us as software developers and to the business? So I have some questions for you, and I can almost see everyone. I ask these questions at pretty much every conference I speak at, and I've spoken at several of the Scrum gatherings. So I want to share with you what I find, what the results are, but I also want to know what you think as well. So the first question that I'm going to ask you is a stupid question, because here we are at a Scrum gathering, and the question that I'm going to ask you is, how many of your teams are doing Scrum? I figure that it's everyone, right? How many people are doing Scrum? I'm waiting for the translation. Oh, very good. Very good. So that's probably most people. That's why you're at a Scrum gathering. Excellent. When I ask how long teams have been doing Scrum, I oftentimes hear different things. When I ask how many people are doing it for a year, pretty much everybody. To when I start to get to 5 to 7 years, all the hands go down. I don't see many teams who have been doing Scrum for more than 5 or 7 years. And that is because the way most teams do Scrum, they accumulate so much technical debt that after 5 to 7 years, they can't get much done. We don't want to be in that situation. Then I ask, how many teams, and I'm going to ask you guys too, please show me by raising your hand, how many of your teams are doing XP? Now at this point, usually at a Scrum gathering, I see people looking around going, what's XP? XP stands for extreme programming. They go, what's that? So I see, about 10 people who are doing XP, about 1 in 10. That's very reflective of the industry. This is what I see when I read the State of Scrum or State of Agile reports. About 1 in 10 teams are doing extreme programming. And when I ask how long they're doing it, again, a lot of teams are doing these practices just for the first year or second year, so they're just starting out. Uncle Bob Martin says that our industry worldwide doubles every 5 years. The number of programmers in our industry doubles every 5 years and has for the last 25 years. And that means that the average level of experience on a team is only 2.5 years. And so how do we solve that problem? Because there's a lot of beginners out there. The way we solve it is sharing information, collaborating, working together, sharing principles and practices together. When I ask teams about the practices that they do, which technical practices. A lot of teams are doing some of the practices. For example, continuous integration. I know that many teams are doing continuous integration. However, very often when I dig a little deeper and look at their servers and look at their code, I find that they're not taking full advantage of continuous integration. They have the CI server set up, but then they have feature branches that prevent the code from actually integrating. And so that can be a problem. And they don't know how to make it so that their code actually does integrate. Or they say to me, oh, we have too many teams. We can't all write out to trunk. We can't all integrate. Well, how many programmers are at Google? 100,000, something like that? And they all commit directly to trunk every single day, many times a day. Well, if 25,000 people can do it, our team can do it too, I think. Teams, one of, I think, the most important technical practice, but it's also the most advanced, is test-first development. But we have to understand how to do it correctly. And a lot of teams have tried it and failed because they don't quite understand how to do it well. I want to talk to you about these practices, so we'll dive into it a bit. But I want you to know that there's a lot more than we can cover in just our 1 hour together. Then I show people this book. This is the book that really made Scrum popular. It's called Agile Software Development with Scrum by Mike Beadle and Ken Schwaber. And I want to just read to you the last 2 sentences of the description of the book. It's printed on the back of the book. It says, this book shows readers how to use Scrum, an agile software development process, to quickly and seamlessly implement XP in their shops while still producing actual software. Using Scrum and the agile process can virtually eliminate all downtime during an XP implementation. So the people who popularized Scrum did so because they believed that Scrum would help you do extreme programming better. And here we are in a world where I go to Scrum gathering after Scrum gathering, and I see people doing Scrum, but very few people doing XP. And that's a shame because these technical practices in extreme programming really enable us to do iterative development. The slides are also in Japanese if you'd like to read them in Japanese. Here are the 9 practices from my book, and we only have time to cover 5 of them. These are the 5 that we'll talk about. The first practice that I want to talk to you about is continuous integration. And this was really the most painful part of doing waterfall development. I remember I used to work at IBM, Yamato Labs in Florida. And I remember one year, I did not even see the sunshine once for a whole 6 months because we were integrating. Life is good before integration when you're doing waterfall, but during integration, that's where the worst bugs show up. And I was heading into work at 5 a.m. every morning before the sunrise, and I was leaving work at 9 p.m. every night after the sunset. And I did this for 6 months. This is no way to build an industry. This is no way to build a career. So integration can be really painful when we put it off. But that same integration server, when we have good tests and when we integrate all the time, can become our most valuable source of information. Because when we do TDD well and we are able to write good test coverage for the behaviors that we're creating, if we make a mistake and change that behavior, one of our tests will break and will immediately notify us. And when I do TDD, I get that immediate notification. I fix it. It takes just a few seconds and I didn't even notice. But if that same defect escaped into production or was given back to me 2 weeks later from QA to fix, it might take me an hour to get back into and figure out where that bug actually was. It could take a lot longer too. So continuous integration can be really valuable if we integrate all the time. But like I say, people, they don't really understand the idea of continuous integration is about integrating continuously. So they build their own little branches and they isolate their code from the rest of the system. And what they're really doing is waterfall. When teams fully depend on their CI server, when it breaks, they can't do anything. So it can be really, really valuable to keep your CI server up and running. I think of continuous integration as really the heartbeat of a development project. And it gives us instant feedback so we can take action immediately, which is really, really powerful. And it is really, I think, the richest source of feedback for software developers. We talk in Agile and Scrum a lot about feedback, right? We talk about feedback from our customers. We talk about feedback from our product owners. But I think the most valuable form of feedback in Agile for software developers is the feedback from our continuous integration server, because they can tell us if we have trouble very quickly, as long as we write good tests to make that happen. In Scrum, we talk about a definition of done, and I have 3 definitions. There's done, which means that the feature works on the computer for the developer who wrote it. But that's really not enough. So Scrum defines what they call done. And done means that the feature not only works on the developer's machine who wrote it, but is also integrated into the build. But I think that's not enough either. So I have a definition I call done. And done means that it works on the developer's machine who wrote it. It's integrated into the build, and we've taken some extra time to make it supportable. We've gone back and cleaned up the code, even though it's working, to make it so that it's easier to read and understand. We want to strive to make all of our code done. Okay? Remember, it costs 5 times more to manage software after it's released than it costs to build it initially. This is one of the most shocking statistics I came across when I was writing my book. 5 times more. And I was looking at that and trying to understand it. It turns out that maintenance is the smallest of all these costs. The largest cost for software after it's released, well, it's not the largest cost, but the cost, it costs about half as much as it costs to build the system to remove defects from it, and twice as much as it costs to build the system to make enhancements to it. The reason that it's costs so much to change existing code is that we don't write software to be changeable. We could, it's not really that hard to do, but it's just not a priority for a lot of companies or for a lot of developers. And so they haven't thought about how do we do that. It turns out that it's very straightforward to do, to make software changeable so that it can accommodate change in the future. And it turns out also that it keeps us out of trouble. It winds up that we don't incur a tremendous amount of technical debt when we do. So I like to think about what I call continuous deployability. And that doesn't mean that we're deploying all the time. We could if we wanted to, but when we ship is oftentimes a business decision based upon the seasonality of our products and our maintenance contracts and other business issues. So the business should decide when to release. But we developers should always build software so that it's always releasable. One, because that gives the business the opportunity to release at will. But more importantly, it reflects the true nature of our progress. You know, it's very easy to fool ourselves in waterfall when we have these defined phases, like requirements, design, coding, integration. We could be in the phase of integration, but it turns out that we actually missed some of those other steps before. And so it's very typical on a waterfall project when we get 6 months into a 12-month project to realize that we're 9 months behind. We were always 9 months behind. We just didn't realize it until our 9 or 6 month into it. And this is why Agile can be very valuable, because it can give us the opportunity to see that we're on the wrong track. And if we can see that soon enough, then we can take action so that it's prevented. So I always like to build software so that it's always shippable. And I include everything in my build, not just code, but everything else the build depends on, like stored procedures and database layouts and build scripts and things like that. And we want to automate the build and make it so easy to use that developers use it all the time. Okay. If it's really hard to use, then developers won't use it all the time. And we want it to be just something that's second nature. So I want to integrate several times a day. I'm sorry, can someone turn off their microphone, please? So one way to encourage developers to do continuous integration is to say that they should integrate at least once a day. And when they do this, the last developer who integrates at the end of the day winds up probably spending hours figuring things out and not getting home on time for dinner. And that's the last time they only integrate once a day. I like to integrate many times a day, several times an hour. Whenever I have the little bit of functionality, I will integrate it. And I run my tests all the time as well, because that gives me that level of feedback. When I look at the server logs of my heroes, the people I most admire in software development, people like Arlo Belshi or Llewellyn Falco, when I look at their server logs, they run their tests on average 3 times a minute, every 20, 30 seconds or so. Think of how powerful you could be as a software developer if you had that level of feedback coming at you all the time. And this is one of the reasons that Agile developers are so successful, is they have this level of feedback. So take the first step. Do continuous integration. If you're not doing continuous integration, this is the place to start. If you are doing continuous integration, you can always do it better. And the way to do it better is to write better tests. It turns out that writing tests in software development is really a key activity to pretty much everything, to a deeper understanding of our code and making our code more resilient to work. We'll talk about TDD in a little bit. The next practice I want to talk to you about is collaboration. And just like other technical practices, collaboration requires skills. It requires understanding and having the right environment in order to flourish. This is a really powerful way to share information, to learn. And the 2 techniques that I really find most valuable are pairing and mobbing, which we'll talk about. I don't know if you can see this picture here, but this is a picture of the C3 project. at Chrysler. This is where extreme programming was born. Some contractors, Kent Beck, Ward Cunningham, and Ron Jeffries, were working on this project, and they came up with a kind of different way of working together. And they were very successful, where many of the other teams were not. And so this was the beginnings of a new way of building software that they called extreme programming. And extreme programming, it's, what now, 20 years old, but they got it right. And so the ideas in extreme programming are really valuable even today. And I know everything changes in the software field, but these ideas are eternal. They're as valuable or more valuable today than they were when they were first written. And they will continue to be valuable because they talk about the essence of software development and the essence of being able to understand complex problems, which is at the center of software development. I like everything about extreme programming except the name. The name sometimes turns off managers, The idea is that we're taking good practices to extreme. That's why he called it extreme programming. So we think code reviews are a good practice. So taking them to extreme, we would sit down with another developer and write code with them. That's pair programming. So we're taking practices that are good and bringing them and making them even better. Enterprise software development is really a social activity. It requires a tremendous amount of communication and collaboration. I've been a software developer most of my life and a nerd. I'm a nerd. They say that we're not very good at conversation, but I disagree. I think software developers are able to talk about a lot of very complex things. I'm not very good at small talk, but I'm very good at talking about very complex things in software development. And building software requires collaboration. It requires to make connections when we communicate, a common set of terminology, a common set of goals and objectives. And I see all of that lacking in most professional software development teams. I go to company after company after company. And again, I'm talking about the top companies in the world. And I see that people have different definitions for what good code is, for how to build good code. And that causes a lot of friction. We need to get on the same page together if we're going to communicate and collaborate. And it's not like one approach is better than another approach. This is the challenge, is that all these approaches can be equally good. But the challenge is that if one developer takes one approach and another developer takes a different approach, when they go to integrate their code, they have problems. And that's why we need to be on the same page. Good. So pair programming, I think one of the most valuable of all the software development practices. It's also the practice that I find hardest to convince developers and managers in the West to try. Now, developers are actually easy to convince. All you have to do is set up a world, an environment, where they can see the benefit. And we're very practical people. If you can see the benefit, then typically you'll find that it's a good practice. Managers are not so easy to convince. They say to me things like, I can't afford to lose half my resources. Well, first of all, we're people, we're not resources. And secondly, pair programming is not about taking turns at the computer. It's about bringing two minds to bear on the same problem. There are many physical challenges that require more than one person. You can see behind me, there's these two bookshelves. Each one of these bookshelves weighs about 500 pounds. I can't lift it all by myself. Clearly, this is a 2 or 3 or 4 person job. If it was me, it'd probably be 10 people. But the movers the movers that I hired, 2 guys did it. I was shocked. So there's a lot of physical things that require more than one person because it's heavy. It's got a lot of weight to it. There are mental things that are the same way, that are heavy, that require a lot of extra effort. And when we're working with another person, then it can be really valuable. It doesn't actually take 50% less time. In a worst case scenario, it's 15% more overhead. But when you're pairing, you have many other advantages, such as it's less code to do the same thing, which means that it's far less maintenance costs. You're producing less defects, so you're actually delivering faster. You're much less likely to be interrupted when you're working with another person and interacting with them. If you're sitting all alone, then it's more likely that somebody can come and interrupt you. So it's really, really powerful technique. And it propagates knowledge across the team very rapidly. When I finish a day of pairing, I'm exhausted because I've worked really hard, but I'm also highly satisfied because I know I got a lot accomplished. Sometimes I can't convince teams or their managers to try pairing. And so I have a gateway process that I call buddy programming. In buddy programming, we take turns driving and navigating, take turns at the keyboard. We actually don't do that in buddy programming. In buddy programming, we work on our own for the whole day. But the last hour of the day, we get with our buddy and we do code reviews. And oftentimes, doing this for a couple of weeks or months gives the team enough confidence to try pairing. And pairing is, I think, one of the most powerful activities because we can learn so much from each other. Another technique that I'm a big proponent of is called mob programming, discovered by my friend Woody Zuhl. And in mob programming, is more than 2 people are working on the same story at the same time. Maybe 3, 4, 5, 6 developers working together on the same story. And it sounds like it would be wasteful, but it is something magical happens when we do this. And people get into this flow. It takes a little while. It's not like pairing. In pair programming, you can become efficient and effective within a couple of days. But in mob programming, it typically takes a couple hundred hours for teams to really get good at mobbing. But the benefits can be enormous. There are other techniques that we use as well. Spiking is where one or a couple of people go off and research some unknowns. So we don't try to figure everything out in Scrum up front. Instead, we go into our sprints with unknowns. And sometimes that stops us. And when it stops us, we have to do a little bit of research. So that's a spike. A spike is doing a little research on something that's blocking us. And in a spike, we say how long it's going to take and what questions we want to get answered. And at the end of that little time box, we see if we actually accomplished what we intended to, or if we need to answer other questions or what. When the whole team does this and works together, because maybe there's some showstopper bug, like the CI server is down, then we call that swarming, when everybody on the team works on it. And when everybody on the team works on it all the time, we call that mobbing. And mobbing is a very, very powerful practice. So like I just said, I oftentimes go into iterations with unknowns because it turns out that it's not as efficient to try to figure out everything up front. It's hard to visualize everything up front. And so it's easier to figure things out as we're in the moment, as we're building something. And when I get stuck, that's when I create a little time box to research. Okay? This helps me shrink the unknown into the known so that I then figure out what's going on. If I can't figure something out, I can still encapsulate the issue. And if I can hide it behind a good interface or method signature, then I know I can deal with it later without paying a big price. When we pair and when we mob, we still do retrospectives and code reviews. But the nature of the code review changes. Instead of arguing about formatting, people tend to go deeper and get into conversations about the philosophy, why they chose one design over another design. And I think this is valuable. So the best workers are the workers who help each other. Today, in Agile, this is job security. It used to be the people who had specialized knowledge was job security. You know, I'm the database guy and I know everything about the database, so you can't fire me. But people in that situation very quickly realize that it's not very ideal because they can never take a vacation, they can never get sick, everybody depends on them. And so instead of having these silos of knowledge in Agile, we want teams to be cross-functional. We want teams to be able to have a knowledge across the system so that anyone can work on any piece of the code. We call this collective code ownership. And it allows people to understand more of the code. And one of the ways to propagate this skill is through pairing and mobbing. Another way is to write good unit tests to support them. So my mentor, Scott Bain, says, always strive to be mentoring someone and be mentored by someone. And I find that that's really good advice. I'm very fortunate in that I've gotten to work with and teach thousands of software developers through my career. And the Agile community is a very tight community. And so the other authors and speakers in the Agile space are friends and associates. So if I have a problem, I can go to them and they can help me. I also have a great opportunity to be able to teach many people. And I can tell you from experience that the very best way to learn something is to teach it to other people. All right, let's talk about practice 5. Create clean code. There's a book by Bob Martin called Clean Code, and there's a series of videos by Misko Havery, the author of Angular, called the Clean Code Talks. So I thought I would overload the term and create my own definition. Clean to me is an acronym. It stands for 5 key code qualities: cohesive, loosely coupled, encapsulated, assertive, and non-redundant. If we take the first letter of each of those words, it spells the word clean. And this is my reminder to focus on quality code. Now, the word quality has been overloaded by lots and lots of people. I'm not talking about the quality factors, what I call the IBLs, like reliable. If I say to you that your code should be reliable, I have not helped you very much because I haven't told you how to do what I've told you to do. But these code qualities are quantitative. They talk about what's most valuable. And we can see how to create more of it. Cohesion, well, let's talk about each one of these things, and you can see how we can create more of them in code. So the first one is cohesive. Quality code is cohesive. And cohesion means that our code is about one thing. Our classes and our methods deal with just one issue. We're not doing many issues. Okay? We model complex things like a person. A person is a complex thing. If we were to model them, they have many different kinds of behaviors: walking behavior and eating behavior and talking behavior. All of these things can be aggregated into a person class. So we can build complex things by aggregating other objects within our object. Okay. Okay. Quality code is also loosely coupled. And we're not striving for no coupling in the system because that's a system that does nothing. We're striving to have coupling where we intend it to be, but no coupling where we don't intend it to be. And because of that, I prefer, instead of using the industry terms, which is loose coupling and tight coupling, which confuses me. I never know which one is the good one and which one is the bad. I prefer the terms intentional and unintentional or accidental coupling. And then we know which one is the good one and which one is the bad. But we get bad coupling not by accident, but by having other code qualities missing. Like when we have a lot of reasons to access a class. If a class is not cohesive, that means that there's many reasons to access it, then we're coupling to it from many different places, and that's not good. So improving cohesion also improves coupling. This is true for all the code qualities. When we improve one, we see the others improve as well. The third code quality, encapsulation, the idea of hiding and having an inside versus an outside for objects. And there are many different ways that we can encapsulate, not just making our data or behavior private. We can hide concepts behind abstractions. We can hide behavior behind interfaces. I teach design patterns, and the way I teach them is that each pattern encapsulates something different. And I think this is really important because I think the job of a great software developer is to encapsulate as much as possible while still being able to do the task at hand. Because the more we can hide, the more we can change later without breaking a bunch of other things. So we want to hide as much as we can. And specifically, we want to hide how we do things and only show what we're doing. This is actually a recurring theme from the very beginnings of how we think about what we need to build, the stories that we write, to writing the code and validating the code. Being able to separate out the two modalities of thought, the abstraction from the implementation, the what from the how. If we can separate those things out in code, it can make our code far more maintainable. And there's various techniques to be able to do this. Quality code is also assertive. This is a code quality I don't see many people talking about, but I think it's very valuable. Assertive objects are in charge of themselves. This is opposed to being inquisitive. An inquisitive object is an object that, in order to do its work, has to access other objects to get access to its state. Maybe the behavior should be in those other objects if it's constantly calling the other object. So assertiveness just says that the behavior and the state the behavior acts on should be in the same class. And our last code quality, high quality code is non-redundant. High quality code is non-redundant. Repetition in learning is good because it helps us deepen our understanding. But repetition in code is always a maintenance issue. So we don't want to do that. And notice I'm using the term redundancy instead of the XP term duplication, because duplication is the most obvious form of redundancy. There are many other forms of redundancy as well. When we iterate through a loop, and when we're doing a for loop in one place, but a for each loop in a different place, but we're iterating through the same collection, that would be considered redundant, even though the code is not identical. And identical code, like incrementing a counter, I++ semicolon, could be there for a different purpose. If it's, for example, iterating through a list of names versus a list of numbers. So it's not, redundancy is not an issue of form, but rather of intent. If we're trying to do the same thing in multiple places, we consider it redundant. these code qualities, and there are many more code qualities in this, but I find that these 5 are just fine to focus on at first. They guide us, they give us direction. Cohesive code is easier to read and understand. Loosely coupled code is more straightforward to test and extend. Encapsulated code means that we're reducing the side effects when we go to change things. Assertive code means that behavior and state that the behavior acts on are together. And non-redundant code means that we're dealing with changes or defects in only one place. When we focus on any of these code qualities, we find the other ones improve as well. And this is really at the core of good code. If you can have these qualities in your code, then you'll find that it's much more straightforward to work with. And I like to say that if you want to increase your velocity tomorrow, the way to do it is to increase your code quality today. I know it's not very sexy, but it's the truth. A lot of times, the thing that slows teams down is technical debt. And so if you can increase the quality of your code and reduce technical debt, you can get more stuff done. Okay. I want to touch on my favorite 2 practices, or last 2 practices. Test first development and refactoring. And they go hand in hand together. I have a little dead end sign here because there is a movement called the TDD is dead movement. It was somewhat popular in the United States about 5 years ago, and I still see people referring to it. When I looked into this movement, I realized that they had a lot of valuable and valid arguments. They talk about test-induced damage. They talk about having problems doing TDD, but this is not an issue with TDD itself, but the way they're applying it. We have to know how to apply these advanced practices correctly. If we do the practices poorly, then we're going to get poor results. The very same medicine that can cure you can also kill you if you take it wrong. Fire destroys homes, destroys lots of things, but that doesn't mean fire is bad, and we should never use fire, right? We just need to understand its parameters, how to work with it. The same thing is true with TDD. It's an advanced practice, and there are many ways to do it wrong. But when we understand how to do it correctly, it is the most powerful practice in software development. It has saved me so many times. It's really, really powerful and useful. And TDD is not a testing methodology like a lot of people think from the name. It's actually a design methodology. It informs us on how to write better, higher quality software. So write the tests first. And there are many things that we call tests in software development. So it's a little confusing. There's acceptance tests. I call these customer tests because they're really about getting clear about what the story is supposed to do, what this feature is supposed to do. An acceptance test passes when the feature is complete, so everybody is on the same page with what the feature should do. Unit tests, I call developer tests because we build them hand in hand when we build the code. This is not trying to make software developers do QA. This is a developer activity. It's not a QA activity. We're not trying to think about the things that can go wrong. And in fact, that's the way to do TDD incorrectly, is to think in terms of QA. Because TDD is a different kind of activity. It's not really about testing. It's really about specifying the behavior that we want to create. And when we think of TDD from that perspective, it gets much clearer on how to build the right tests for the behavior that we want to create. So TDD is not about putting QA out of a job. Now, one of the things that we get from TDD is a set of regression tests. And if we do TDD well, the regression tests can serve us in refactoring code. And so this frees up QA and the testers to focus on more valuable things rather than black box testing. So they think about performance, they think about security, they think about other things like usability. And this is where we get to have the QA people be very creative, just like developers are creative, because we've automated the validation process, okay? So software development is really about automating other industries, so we should find ways to automate our industry as well, right? And writing good unit tests and automating that is a great way to take away the sort of rote work and only give us the ability to, only allow us to do the creative work. Tests articulate the behavior that we want to create. So I find that I write far less documentation for development when I do TDD, because the best documentation and way to call my API is embodied in my test. This is true for most of XP. Extreme programming is really about replacing the non-coding activities that we developers have to do traditionally with coding activity. And when developers realize that that's really what XP is about, that's when they get excited and want to get on board with XP. Because rather than sitting in meetings or reading long-winded requirements or spending hours going through debuggers, we have these other practices that are much more fun, that are much more productive. And so we feel a lot better, I think. So write good tests. And I think that all of Agile boils down to this, that ultimately, if we understand what a really good test is, then we can really excel at Agile and Scrum. But unfortunately, like my friend Misko Havery says, I rarely meet a software developer who knows how to write a good test. We all know how to write a test, but what we're saying is a good test. And to me, a good test has 3 key characteristics. It always fails for the reason you intended it to. It never fails for any other reason. And there should be no test in the system that fails for this same reason. In other words, a good test is unique and tests behavior, not the way we implement the behavior. It tests the behavior itself, not how we get the behavior, just the behavior itself. And that gives us the freedom to refactor, to change how we implement the behavior without breaking the test. This is when TDD supports us in making last-minute changes to our code. This is the dream of Agile software development. But when we write poor tests, when we write tests that depend on implementation details, or we write too many tests because the developer says, well, 1 test is good, 2 tests is really good, so 100 tests must be amazing, so I'm just going to write a lot of tests. But this is not a good thing to do, because when we go to refactor our code, many tests break. And so the same approach that was supposed to support us in being able to safely refactor our code actually prevents us from refactoring our code, because we wrote tests against the wrong things. We didn't write tests against behavior, we wrote them against the implementation of the behavior. And so we changed the implementation and the test break. So writing good unit tests are really about writing tests that are about the what, the abstraction, rather than the how, the implementation. Okay. And TDD gives rapid feedback. It's really easy to find bugs when you start writing something and immediately your test fails, because it immediately tells you, oh, something went wrong. So good unit tests provide regression and give us that level of feedback that we need to be able to move fast. And as I mentioned, the top developers I work with, they run their tests frequently, more than once a minute, and they get lots and lots of feedback. Okay. And TDD also supports refactoring. And this is, I think, one of the most important skills for software developers to have. This is the first edition of Martin Fowler's book. He last year came out with the second edition of this book. I strongly recommend it. It has been translated into Japanese. This book teaches some basic techniques to be able to go from one design to another design. And when you know how to do that, it becomes incredibly powerful and useful because you're no longer stuck. You always have options. I had the honor of speaking at DevOps Days Tokyo a few years ago. And while I was on stage, I actually came up with this metaphor, which is to clean the kitchen before making a dinner party. So a lot of times it's very hard for people to understand what's going on inside a computer and why these things are important. So using metaphors in the physical world can oftentimes help people. So imagine you want to create a dinner party for your friends, a really fine meal. But you've been very busy and your kitchen is a mess. There are dirty dishes everywhere. Your sink is overflowing. There's no counter space. The floor is dirty. Everything is a mess. What do you do first? I think everyone would say the first thing we need to do is clean the kitchen. It's very hard to try to prepare a meal in a kitchen that's completely dirty. So we clean the kitchen first. The same thing is true in code. Before we go and add a feature, we need to clean the code up so that it's straightforward to add the feature. And that will allow us to add the feature more readily. So clean the kitchen before preparing the dinner party and refactor the code before adding a new feature. And write testable code. Regardless of whether you do TDD or not do TDD, you can write testable code by simply asking yourself, how testable is this code I'm about to write? And if you think that it's hard to test, then change it, write it differently. Okay. And TDD is an incredibly valuable process because it's a second check. It's sort of like an angel on your shoulder. It's a different perspective on your code. It's your caller's perspective. That's what a test is. So really, you're thinking about your code from the internal state, but also from the caller's state. This gives you two perspectives, and the very definition of the word understanding, it's to see some situation from more than one perspective. And that's what TDD provides for us. So it gives us a deeper understanding. And I can do test-driven development in almost any state. I often code half asleep at night watching TV with my wife because TDD is such a powerful methodology. It keeps me on track. And you're probably a lot younger than me, and you're probably a lot smarter than me too. But I gotta say that, you know, being an old guy, a lot of my quickness has diminished. But that's okay because I'm still able to write lots and lots of code because I found methodologies that support me. But I've seen TDD fail. In fact, I've seen it fail more than I've seen it succeed. One developer said to me, we'd have to abandon TDD because it would take a week to refactor my tests, only a day to refactor my code. I said, really? He said, yeah, all these things. It turns out when I looked at their code was beautiful. It was really clean, but their tests were a mess. They didn't realize that their tests were also important and valuable code, so they didn't spend much time refactoring it. I spend more time refactoring my tests than I spend refactoring my production code. but it's worth it because my tests give me such great value. Managers often ask me, well, how do I introduce TDD to a team? And you typically can't. The best way to have a team assimilate TDD is to give them a positive experience of it. Have them actually do it on a small project and see the benefits. And that's what I do in my advanced Scrum developer class. We build a full application in the 25 hours that we work together. And we do it test first in a mob or in pairs using all the practices that we talk about. And we find that we have a great deal more confidence in our code. And a lot of people say this, that when they do TDD, they have far less defects. In fact, the statistic from the Nagapan study, which is the most famous study on TDD, is that defects are reduced up to 80%. That's phenomenal. I know of no methodology that can claim an 80% reduction in defects. One methodology, but TDD does this. They say, though, there's a price that you have to pay, which is that it's slower. This is not my experience. I've been doing TDD for almost 2 full decades, and I find that I'm much faster when I do TDD than before. But again, we have to understand that TDD is not about testing. It's about specifying behavior. It's about articulating behavior. And when you see TDD from that perspective, everything gets clear. Then we can agree on the right number and kind of test for any kind of behavior that we can think of. That allows developers to get on the same page and really communicate at a far deeper level. And this is one of the other reasons that I think TDD is so valuable. So become test infected. This is the term that we use that describes the value of doing TDD. People who love doing TDD are test infected. I'm test infected, and my goal when I teach the advanced class is to get other developers test infected. Most of the developers who finish my class, actually do TDD ever more like I do, because it's such a powerful process. Okay, our last practice, I want to go quick because I want to give us some time for Q&A as well. If you have questions, please think of them, and we'll do them in just a few minutes. But I want to touch on just this last practice, which is a critical and essential practice, is refactoring. Refactoring is changing the internal structure of code without changing its internal behavior, external behavior. Our goal is to change how we do something without changing what we're doing, okay? And it really drops the cost of ownership for our software, makes it easier to understand the code, easier to add automated tests, easier to add new features, and to do more refactoring. I don't think any of us would buy a very expensive car, and because we paid so much money for it, insist on never taking it to the shop, never putting oil into it. The car wouldn't last very long. And software development is not a write-once activity. Software development requires constant care and nurturing, requires also constant refactoring. There's a step in the TDD process for refactoring. So we do refactoring all the time in the small, but that doesn't negate the need to refactor in the large every 3 to 6 months, because we learn in chunks, and we want to bring that learning back into the code so that people who are reading the code in the future also have that learning. And that's one of the main benefits of refactoring in the large. So every 3 to 6 months, I typically take a full 2 weeks and refactor the code, clean it up, make sure it's readable and understandable. And that pays me back because it reduces the amount of technical debt I have. I work with the credit card industry, among many other industries, and I like to pay my bill in full every month. They call people like me a deadbeat because they don't make any money on us. I want you to become a technical deadbeat. I want you to pay off technical debt as quickly as possible. We still need to incur technical debt sometimes, just like we still need to use our credit cards sometimes. But when we have the opportunity to pay it off, we want to do that. So when code needs to change, and legacy code, I think of more as landmines than time bombs. So if it ain't broke, don't fix it. And very often, legacy code works just fine. But when we need to add features to it, that's when we have to start to think about how do we do that? And how can we refactor the code so that it's more straightforward to add features? I want to just touch really quickly on some techniques around doing this. There's something called a pinning test. This is a broad test because maybe the code is so hard to work with, we can't write good tests yet. And so we write a broad test that we have to run frequently, like every time we make any little change. And if it fails, we know that it's the last thing we did that caused that failure. Dependency injection allows us to inject dependencies rather than call them directly so that we can test and inject a fake instead of the real dependency. It makes our tests more robust. There's other techniques. System strangling is a technique that Martin Fowler talks about in his book, where you can actually refactor code that's in production, and branch by abstraction is a technique that uses something called feature flags over branches in version control. We covered this in great detail in the class. And what we want to do is really refactor so that we can accommodate change. This boils down to making the code clean, make it understandable, add in tests so that the code is safe to work with, and then we can do more complex refactoring. These are my 3 favorite books on the subject. I already talked about Martin Fowler's book, Refactoring. Michael Feathers wrote a great book with a bunch of techniques called Working Effectively with Legacy Code. And another book that I really like is called Beheading Your Legacy Beast. And not to forget to mention my book, which really takes a different approach with working with legacy code and talks about the reasoning behind it. Good. So there's a technique called the open-close principle. It's a principle that says that we would like to write code in such a way that when we have to add a feature, we're minimally changing existing code. We can add lots of new code, but we don't change a lot of existing code. And when I ask developers why, they immediately know the answer. We introduce defects when we're working with other people's code, so we get scared to do it. Okay? So refactoring is to the open close is really saying, make it so that adding a feature is actually 2 steps instead of 1 step. First, create the space to add the feature, and then add the feature. It's like making the dinner party. First, we clean the kitchen, then we make the dinner party. Developers like to do those 2 steps together, and it is orders of magnitude harder when you combine these 2 steps. So break them apart, and then you'll find it's far easier. First, create the space, then add the feature. And we want to refactor to support changeability in our code so that we can basically make changes to our code without the fear of breaking many things. So I have a saying, in the West, there's a saying called do it right the first time. But I find that it's wasteful to do that because oftentimes we're not sure what the right thing to do is. If we only have one example of something, we're not sure what the right abstraction is. So if I get only one example, I code it concretely and I wait for the second example. And when the second example comes in, that's when I can see what the right abstraction is. So that's when I add a design pattern or add an abstraction. And so this is a process of emerging our design. So the true spirit of Agile, to me, it's summed up in the first principle in the Agile Manifesto, which says our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Okay? So in order to do that, we must not only do the practices, but really understand them as well. Good. So thank you. This is just scratching the surface. We will do Q&A in a moment, but I want to point out a couple of other resources that you can go to. I have a blog. I'm in my 12th year. I have hundreds of posts on my website, tobeagile.com. It's in English, but you can use Google Translate to translate anything from English on a web page into your native language. I have a newsletter that you can sign up for, and I tweet about every day. I have a book. This will also really, really help teams, and I'm so grateful that it has been translated into Japanese. Please get this book and check it out. I think you'll find a great deal of value if you're interested in these technical practices. And you can also attend one of my classes. We offer Certified Scrum Developer and Advanced Certified Scrum Developer classes in Japanese. So it's translated, and the CSD, we have one coming up, I believe next month on the 14th of February. So if you're interested in taking these practices further, I'd love to see you in that class. And here's more details about it. And let's do Q&A. So are there questions?
Hi, thank you, David-san. Let's take the few questions. So,
Yeah, please.
どなたでも大丈夫です。どの部屋からでも大丈夫なので、どうぞ、クエスチョンの方、前に出てきていただいて話していただければ大丈夫です。はい。Please come to in front of the front mic, please. Yeah.
Okay, hello. Thank you so much for really enlightening talk. I have been learning about these concepts like individually as a programming, like in the programming layer kind of mindset. How can I scale this more up to like a more concrete, systematic understanding of like XP and what you were talking about today? So I think a good place to start would be probably your book and the CSD. Are there other like recommendations that I could look into? And another question is that, is there like a good way to enhance that from a personal understanding level to scaling it up to like an entire team level collaboration, communication kind of manner? Is there like a way to practice that maybe in the team that I'm currently in?
These are great questions. And I would say 10 years ago, I would have had a really difficult time answering it. But I can answer your first question because there are so many great resources now. I'm so impressed and excited when I see, not so much in the books side today, but like there are YouTube channels and websites for Agile developers that really have great information. So as you said, the book, but so many other people in the Agile community also have good books, the Refactoring book and Michael Feather's book. And there's now a couple of YouTube channels that I'm finding really interesting. Dave Farley, I mentioned the Clean Code Talks and Google Tech Talks. So there's lots of resources out there if you're looking for it. But I think it's really find the content that resonates with you. If it makes sense to you immediately, then that's good. If it's like, oh, this doesn't quite, I don't see how this applies, then maybe it's not so good for you where you're at right now. You know? So look for things that make the most sense. And I will plug my book again because I think that it will help.
Okay.
The second part of your question is much harder. How do you, okay, so now you have that knowledge. Now you got some insights. How do you share it with your team? I've been working on trying to figure that out for most of my life. And there are ways to do it. I think that basically pairing and mobbing is the best way on teams to do it. So learn how to do that well, and that'll help a lot.
Okay, thank you very much. And one last quick question. So when I'm looking for those like resources that really resonate with me, like, are there any kind of maybe things that I should be careful about, like maybe some pitfalls or things that aren't really necessary as I wouldn't say like harmful, but not
Yes.
not
There are,
generally
and so
well
many-
intended. Yeah.
I didn't want to get into it because it would actually take more time than we have, and we
Yeah.
do discuss it in the classes.
Okay.
But things like story points, there are some Scrum behaviors that are not ideal, that could be improved. So rather than using story points and having different size stories that you have to, deal with in terms of story points, get good at the skill of breaking stories down so that all stories are one size, small. And then you don't need to use story points and your estimations become far better.
Okay. Yeah, I'll
we're-
definitely be careful. And thank you so much for your talk.
You're very welcome. Other question?
If they have the question, please turn on your mic in your remote side. Yeah, in Zoom.
リモートで質問あります。
Go ahead.
講演ありがとうございました。非常に興味深かったです。最初の方にですね、XP を導入しているチームとか、スクラムうまくいっているチームは10分の1、さらにもっとうまくいっているチームはその 1% ぐらいでしかないというふうな話があったと思うんですけれども、一方で、
Yes.
昨今北米ですとかで発祥とかヨーロッパとかで発祥の、DevOps とかっていうのがどんどんアジャイルの次の概念としてできていると思っていて、それによってフォーキーズのメトリックスとかの概念が出てきて、より生産性が高いチームが観測されるようになってきたと思うんですが、その一方でおっしゃられた通り、まだまだスクラムとか XP の導入が進んでないっていうこの現状みたいなところがあると思うんですが、それは、単純に二極化してきているのか、それとも、実際はスクラムとか、DevOps につながるようなプラクティスが浸透してきた結果、より先に進んでいる。
Scrum and DevOps, as a result of the spreading, are the teams getting more productive, or do you think this is dividing into Scrum and DevOps?
Interesting question. And I'm not really sure. I see this trend as well. I think of DevOps as a kind of Agile, a kind of Scrum, or a kind of XP, because it incorporates some of the XP principles. But and continuous integration is like I said, at the center of all Agile software development. DevOps itself, though, although it's really valuable, I don't see very much dev in DevOps. Like, DevOps doesn't include a lot of developer activity. It includes the infrastructure the developers use, but then we have to use that infrastructure correctly. Like I said earlier, the success of continuous integration, which to me is the shining star of DevOps, is dependent upon writing good tests. So writing good tests is at the core of everything. So if DevOps encourages developers to do more TDD, then that is great. And if it encourages developers to integrate as they're building software, then that is great. And that is the intention of DevOps. Gene Kim was the other keynote at the DevOps Days Tokyo, so I got a chance to get to meet him and know him. And I followed many of the other DevOps people. And I was just watching a video from Dave Farley just earlier today, and he was saying the very same thing, which is DevOps is really valuable, and it's a gateway into some of the other XP practices. So I don't think it's a replacement, but really kind of a focusing in on one piece of the puzzle. There are other pieces as well. There's no one solution to everything in software development. Did that help answer your question? Are there other questions?
はい、
Yes, yes, thank you. Thank you very much.
You're welcome.
And yes, thank you. That answered the question.
Good, good. Do we have time for more?
Are there any other questions? One question in the main hall.
Cool. So can you hear me? So thank you so much for the presentation. I just have one question, just some background. So I'm not a product owner or a developer, I'm a UX UI designer. And I was curious, in kind of general terms, it doesn't have to be about what you spoke about today. My question is, how should designers help developers when the developers are implementing extreme programming? Is there anything that we can do to help that, or any kind of ways we should be working with developers?
That's a great question. And we want our UX people to work in tandem with us and to sort of design the UI as we're designing the system. And very often it informs us quite a bit. So we want our UX people to work with our customers or product owners or customer representative so that they can inform you on how to build stuff that's more usable for them. And that will also help the developers understand as well. The key to doing XP and UI is to not put a lot of business rules or any business rules in the UI layer. Okay, because developers often ask me the question, it's not your question, but a related question, which is, how do you test the UI? And the answer is you don't. You make the UI dumb, and you put your business rules in good testable objects that call the UI. Did that help answer some of your question?
Yes, thank you. So having the designers working closely with developers so they can explain kind of requirements in the voice of the users, then also discussing with them on where business rules are, then explain those business rules so they can create it in kind of the back end and not like the UI itself.
Yes. Now remember that the UI is the part of the system that our users see. So it's the part of the system that our users can actually give us feedback on. So very often the feedback that we'll get will be feedback to you, and then you'll translate it to the developers. You know?
Yes. Awesome. Thank you so much today.
You're very welcome. Thank you.
Okay, time has come. Yeah, that's great questions. Thank you so much. And great talk, David-san. Thank you so much. It's a precious time. So yeah, I'm very happy to have your session here. Yeah. Please keep in touch. Anytime to ask David-san in their email or something.
Yes, please. If there are questions for me afterwards, then please feel free to send me an email.
Yeah.
Could you contact me through Agilego or you can my website?
Your email address to the chat or something?
Yeah, you can get my email through my website, tobeagile.com.
Yeah, good. Please check the To Be Agile website. Yeah, thank you so much. Thank you so much, David-san. Please
thank you.
Give it a big applause. Thank you so much. Thank you.
Goodbye.